Welcome to this lecture. Today we will discuss risk assessment. Although you have seen that what is risk, what is likelihood, what is risk profile, also we have explained fault tree analysis, event tree analysis, bow tie, then all the hazard identification techniques including PHA, FMEA, then some other techniques also. So, particularly in PHA we have used initial mishap risk index, final mishap risk index, which are basically qualitative in nature. Then event tree, fault tree we have used probability values to find out the top event probability and then also find out the probability of the accident scenarios. And in bow tie you have seen the probability of the accident paths and the qualitative as well as the quantitative aspects of risk assessment, particularly from probability of failure top event point of view we have already experienced. And from consequence or impact point of view we have given you the qualitative aspects, that means the severity classification or loss classification. In FMEA RPN you have calculated and there we have given you 10-point scale for probability calculation and severity calculation as well as detectability calculation. And in PHA, that means 5-point and 4-point scale for probability and severity we have discussed, but as such for consequence assessment the quantitative part we have not given to you, because this is although important, but it is a very critical and difficult part, particularly how to estimate the cost of accident or cost of losses arising out of any accidents that happen in industry or other scenarios. Nevertheless, although we have explained the risk assessment in piecemeal manner, but the complete that picture of risk assessment not given to you. Today, I am just actually documenting all those issues in one umbrella, and we are saying it is risk assessment. And then I will basically recall many of the things in my lecture what you have already known, and further basically that how to quantify the individual and societal risk with an hypothetical case I have explained here. I hope that you will like this lecture. So, the contents for today's presentation: a risk assessment process which we will start with. Then with reference to a hypothetical case we will discuss risk contour map, then individual risk assessment and societal risk assessment. And interestingly that this particular lecture I have prepared based on the concept given in this paper, that is simple problem to explain and clarify the principles of risk calculation by Hendershott, this in 1997 October, and this was published in a conference, international conference and workshop on risk analysis in process safety. Very interesting paper, and it gives us lot of clarity, and based on this I have prepared the hypothetical case. One hypothetical case is given in this lecture in this particular conference paper. So, you may go through this and you can get that document also. And here the same concept I will be using with a different hypothetical case similar to the one given in that paper. Risk assessment process. Risk assessment process is very much known to you. Several times we have discussed in different occasions. So, this is basically a formal process what I am saying. So, description of intention, why you are interested to conduct the risk assessment, what is the purpose, what is the intention, Is it to identify hazards and ranking them, or is it to identify the accident scenarios and ranking them, or it is basically maybe some other purpose known to the risk analyst. Hopefully, we all will agree with that. In this particular lecture, we are basically interested to know that there will be different hazards, different accident scenarios, and those accident scenarios may be realized, may not be realized depending on where you are working, and that is why the potential accident scenarios we can say, and we will be interested to know the risk of each of the potential accident scenario. That is what is the starting point for us. Please remember that you may go for risk per hazard also, you may identify risk for accident scenarios also. So, it basically, if you start with hazard, then from hazard to all accident scenarios you have to find out, and then all those accident scenarios risk if you know, and then that will be to a sum total and you will be getting the hazard wise risk accident scenario. Similarly, you may be interested to know the risk of job wise risk. So, a job may contain several hazards, and then job to hazard, hazard to accident scenario, then you aggregate the things, finally job wise risk you will be able to get. Similarly, location wise risk also you will be able to get. In one location there will be different jobs. So, then jobs to hazards and hazards to accident scenarios, again summing up. So, for an organization as such, then organization, then different departments, then different sections, then maybe different locations. So, again in different location different jobs, and in different jobs may be hazard 1 to hazard 2 different hazards, and in again hazard 2 different scenarios, accident scenarios. So, that accident scenario, if you know the probability of this scenario happening, you will be, when you aggregate you will be getting this, when you further aggregate you will be getting this, when you further aggregate you will be getting for location, getting per section, department, organization. So, that means accident scenario is the bottommost part for our calculation. So, okay, whatever this may be your intention, and that means if you are interested in the department wise, from scenario to department you have to aggregate. So, whatever you do, but ultimately you have to know the hazards and how accident scenarios is taking place. So, you all have seen the fault tree and event tree. That means, we started with the top event and then we have gone to different scenarios. So, these scenarios and the top event, why top event, different probability you have calculated. I am repeating what I have already discussed, and then these probability values you can calculate, and this scenario ultimately lead to particular loss. So, once you quantify this loss, this probability of this scenario times the loss will give you the risk. These two are coming under that probability coming under assess the frequency of accident scenario, and the loss part is coming under assess the consequence for accident scenario. Okay. So, now when you multiply the probability time the loss, you will be getting the risk. This part is known to you. So, there are many techniques we have used, and you can go by PHA with qualitative way, you can go FMEA with RPN way, you can go for event tree, fault tree and event tree, and then find out the probability also for this. Okay. So, once you assess the risk, then what are the steps? First is intention, second identify hazard for all accident scenarios, then for every scenarios find out the consequence and find out the frequency per year what is going to happen, then multiply the two, you get the risk of accident scenario, and then you may find out several accident scenario, and then and then this side maybe you can find out the probability. So, this is the risk profile. So, that risk profile also you can create. Other way, okay, once you multiply with the consequence, you will basically find out the risk, then all scenarios and risk, that also you can plot, that is also risk profile. Okay. Ultimately, we are interested in the risk. Okay. So, now once the risk is assessed, what is required? You require to compare the risk with target. Now, target can come from different sources. One of the issue is maybe LARP, ALARP, as low as reasonably practicable. So, LARP can help you to define the target, or you define the risk target for your organization using any of the suitable techniques, not necessarily you have to go by LARP. So, compare risk with risk target. This is basically that if there is any risk which is above threshold, those to be reduced. So, and that reduction of risk is basically the action. Here decision is you have to reduce risk, and accordingly what action you want to take. Now, those decide actions may be accept the risk if it is below the threshold, reduce the risk if it is above the threshold, transfer the risk when you are not in a position to reduce the risk, you may transfer the risk to some other parties, but please keep in mind this is the least preferred one, because even if you transfer the risk, but somebody else will be exposed to this risk, that is not desirable. Okay. So, maybe you will transfer to that group who are having the ability to reduce the risk, then it is fantastic. Okay. So, this is the nutshell the risk assessment process. So, to repeat that you can go by qualitative way, that means the 5-point Likert scale or 10-point Likert scale for probability and consequence, like PHA you have done. You can go for that RPN value calculation the way in FMEA we have done, but in general risk assessment we say risk equal to P into C, probability and consequence, and we basically will be interested to have the quantitative probability value here and some quantitative value there, if not maybe some index value at the consequence level. So, here someone may be interested to use the fault tree coupled with event tree, which is basically bow tie. So, that means all those techniques are essentially hazard identification and risk assessment techniques. This is the process this way. So, if you start with your organization, then you find to divide the organization into departments, some more smaller unit, maybe division, subdivision, then subdivision to department, department to your maybe section, section to location, location their different jobs, and then again you find out the job wise hazard, and then hazard wise accident scenarios, and finally find out the risk related to accident scenario, and you aggregate to higher level to get the risk per job, risk per location, risk per your department, risk per your organization. So, that sense. So, that is what you have to do. So, that is what is our formal methodology for risk assessment. Okay. Now, let us see that how we will do this risk assessment with a hypothetical case, and assume that actually what does it practically mean risk assessment in the plant. So, hope that the hypothetical plant we have considered, this is my plant boundary, and there are different people working at different locations. So, there are different locations which are also very important, like A, B, C, D, E, F, these are the locations, and let that we know the source of hazard. There can be one hazard source, there can be multiple hazard source, and we know that the hazard to accident scenario, that path is also known. That means you have bow tie available for your plant, bow tie available for your plant. If bow tie is available for your plant, that means you know that what are the accident scenarios that could happen in your plant, that is the potential accident scenarios. And interesting to say that even if there will be multiple hazards, but maybe many hazards will ultimately result in the similar accident scenarios. So, for the time being you just think that in this plant there will be some gas emission, there will be low impact fire, there will be explosion, there will be high impact fire. Okay. So, that means these are the four that is the finally accident scenario or incident outcome scenario. I am saying that accident scenario, sometimes we use incident outcome scenario, that is developed. There can be some more accident scenarios, but we are assuming that this is basically complete for this plant. Then using fault tree, we know that the hazards, we know how the hazard lead to these scenarios. So, that means the fault tree is known to us, event tree is known to us, that means the bow tie is known to us. Using this bow tie concept, whatever we have discussed earlier, we have identified the frequency per year. So, that means emission frequency per year, then emission frequency means emission to the for example 1 here, that this is the area. So, emission to this area, this much area will be affected, that is what we are saying emission. So, then low impact fire with this frequency, high impact fire with this frequency. Please remember that these frequencies are also hypothetically in nature. So, there is no practical meaning here, practical value here. It is basically meaning is that okay, these are the frequency per year that could happen. So, with this information, you want to know what is the individual risk and societal risk. Individual risk means, suppose you are working in this plant, suppose you are working here, you are this person. Okay. So, what is basically going to happen to you? What is the risk you are exposed to? So, we will not consider these people because they are not affected. So, if you see that these are the first scenario, second scenario, third scenario and fourth scenario, these are the accident scenarios, and first scenario is this is the affected area. So, if emission takes place, this much area will be affected. Then second scenario is this. So, this much area will be affected. Third scenario is this much area is affected, and fourth scenario is this much area is affected. So, so suppose we are interested to know people working at location A, location B, location G, like this at different location, what is the individual risk? This is number one. And another one is, so we have taken all the location in the damaged area only, where affected area. We have not taken location out of the affected area. So, out of the affected area, you consider location, and if we assume that these are the scenarios only, then definitely at that place people will not be individually, they are not going to be affected. So, another one is the societal risk, the definition I have given you earlier. So, that in a group what is the effect, these two things we will calculate. Okay. So, what is our further assumption is that means we are basically talking about the here our risk is basically risk of fatality risk. Okay. So, if the damage within damage area, the fatality probability of fatality equal to 1. Without beyond the damage area, probability of fatality equal to 0 beyond damage area. So, that is another simplification, but it is not true always, because the location at which the accident has taken place, people will be affected there more, and then slowly when you go away from the accident zone, the effect will be less. but we are expecting that as the accident scenarios are very fire, explosion and emission of gases, they are really a fatality prone accident scenarios, or other way I can say that we have considered only those accident scenarios which are fatality prone. So, then this assumption is valid. So, then if I want to know what is the individual risk, fatality risk, then what is the frequency and its probability. If the location at which we are interested to find out the fatality risk, if the location is out of the damage area, this will be 0, but that value multiplied by 0, so individual risk is 0. So, here Fi is frequency of incident outcome or accident scenario 1, I probability of incident outcome or accident scenario that result in a fatality at location xi. Suppose you are here at B. So, it is within the damage area, fatality probability will be 1. You are here beyond the damage area, fatality probability is 0. So, that is what is given here. Then what is the total individual risk? Individually I equal to 1 to n Ri I. What is this? How many? That means in every area, suppose every location, it may be affected by one accident scenario, may be affected by multiple accident scenario. So, that is to be taken into consideration. Suppose you are working in C. What is happening? C is affected by this one, that is impact 3, C is affected by this is impact 2, as well as this C is also affected this one, this one is impact 4, and C is affected by 1 also, impact 1. So, someone who is working in C, he is affected by all the 4 accident scenarios. So, the probability, or I can say individual risk, will be sum of impact accident scenario 1, accident scenario 2, accident scenario 3, accident scenario 4. For example, suppose someone who is basically working at H, if you see that it is basically affected by this one, scenario 4. So, someone working at location H, his probability or fatality risk will be related to the scenario 4 only, others will not be considered. Okay. So, that is, and then total risk, that is why the total individual risk fatality geographical location like this. So, what is IRXY? The individual risk of fatality at geographical location XY from incident outcome case I, probability fatality per year. Here we are using incident outcome case, but again I am repeating, it is nothing but accident scenario I. I hope you have understood. Let me repeat. You are interested to know the probability of fatality of a person working at any place of this, at a designated place in this plant. That designated place may be A, B, C, D, E, F, G, H, I or any other which is not designated. So, then what you want to know? You want to know what is the individual risk of a person working at location A. First, what you require to know? You require to know what are the accident scenarios or what is the effect zone or this place is under which effect zone. Is it effect zone 1, 2, 3 or 4 or any other? Here we have 4 different effects, 4 different scenarios. So, then you just find out the frequency. Frequency means basically that number per year, that through the bow tie you will find out. So, if the particular location is affected by many of the accident scenarios, then their sum will be added up, and that added that risk value, this formula will be added up here, that is the individual risk. Now, let us see. For example, if we consider this one A, B, C, D, E, F, G, H. So, A, B, C, D, E, F, G, H. So, we have considered 1, 2, 3, 4, 5, 6, 7, 8, 8 locations we have considered. A is affected by 3, B is affected by 1, C is affected by 2, 3, 4, 1, 2, 1, 2, 4, 2, 4, 1, 4 like this, but I think I have to just check here. C is affected by 2, sorry, C is affected by this is C. So, this is affect this one and this one. Okay. So, 4 all effect is there. So, when you are summing up, all will require to be summed up. For the timing, as it is a hypothetical case, so what we have written that C is a 2, 3 and 4. What is 1? 1 is this one is this. So, 1 is this. So, that means I can write like this. Then this place will not be affected by 1 if we consider like this. I hope you understand. Sometimes mistake is good. So, then what happened? If this is the case and you have to find out basically the incident impacting zone, and then all the corresponding probabilities are probability values are summed up, and then this is the plot. This is the plot. So, C and C is the most problematic one, then G, then E like this. Okay, so this is your individual risk. Now, we will be interested to know the societal risk. What is societal risk here? Societal risk means a group of people affected by the risk. So, what will be here we will be using FN curve. What is FN curve? Basically, we will discuss. The first step of FN curve is for the example problem is to calculate the number of fatalities resulting from the incident outcome case as determined by Ni, that probability Xi, Yi, Pfi, where Ni is the number of fatalities resulting from incident outcome case I. That means you have to find out how many people are exposed to accident scenario I. So, for in individual case we have not discussed how many people are exposed to. Here how many scenarios are there? 1, 2, 3, 4 scenarios are there. So, what you require to know? You require to find out the number of people, that number of people resulting from each scenario as determined by the number of people exposed to each of the scenarios. That is basically the, if they are exposed to, their fatality is also, they will be fatally affected. Okay. So, how many exposed to 1? Here 1, 1, 2, 3. How many exposed to 2? How many exposed to 3? How many exposed to 4? Like this you have to find out. So, then so if there is calculation mistake, you please rectify, but this is what is issue. So, you see that number of people exposed to 1 is 3, number of people exposed to impact zone 1 is 1, 2, 3, 1, 2, 3, number of people exposed to 2 is 1. So, 2 means this one. Okay. So, number of people exposed to 2 is 1, number of people exposed to 3 is 2, number of people exposed to 4 is 1, 2, 3, 4. So, fine. So, 3, 1, 2, 4. So, there is no computation calculation mistake here. Now, what is the frequency per year for the incident outcome 1? So, if you go back, what is this frequency per year? So, you have found out frequency per year. So, first one, this is the frequency, second one, this is the frequency, third one, this is the frequency. So, like this. So, as it is per year, that is we are saying frequency. Sometimes you may say this is probability also. So, we are using interchangeably this one. So, this one you just see that 1, then 2, then 3 and 4. So, this is the frequency, or other way I can say basically probability of fatality. So, then what we are plotting here, this said number of fatalities and this said frequency n or more of fatalities per year. This is frequency per year. So, what you will do? You just arrange this in ascending order. So, which one is which impact zone having the less number of fatalities? 1. So, it is incident outcome 2. So, 2 1. What I have done? 1 2 3 4, that way ascending order we have arranged. So, 1 relates to 2, then 2 relates to 3, 3 relates to 1, 4 relates to 4. So, this is what is basically in ascending order, means 1 fatalities, 2 fatalities, 3 fatalities, 4 fatalities. So, then their corresponding probability values. So, now 4, what is the probability or frequency per year? Frequency of n or more fatalities. So, frequency per year 5 into 10 to the power this. If it is in first one zone, it is 1.95 into 10 to the 1 this. If it is in zone 3, impact zone 3, 4.5 into this. If it is 2, 2 means 4 into this. Okay. So, what we require to know? We require to know the frequency n or more, that means it is cumulative one. So, what is the maximum number of fatalities here? It is 4. So, if we want to know that frequency 4 or more, then what will be the means number of fatalities 4 or more, what will be the cumulative frequency, that this part per year? It will be 5 into 10 to the power minus 7. So, that is what is the point here, 5 into 10 to the power minus 7. Then we are going to 3 or more. So, that means what happened? These two will be added and ultimately the result will be this 2 into 10 to the power minus 5. So, 2 into 10 to the power minus 5. Then when 2 or more, then the first these 3 will be added. So, I mean this in plus this. So, ultimately 6.5 into 10 to the power minus 5, 6.5 into 10 to the power minus 5. And finally, 1 or more, 1.5 into the power minus 4, 1.5 into 10 to the power minus 4. Okay. So, like this. So, what is happening here? That 1 or more fatalities, what is the frequency per year? This. If we say 2 or more, this, 3 or more, this, 4 or more, some value here. So, this is known as frequency number curve. So, this way the societal risk is measured, and I hope you have understood this. Okay. So, you may be wondering that why this kind of curve, because here what happened, we have considered the probability of fatality if it is probability is 1 if it is under the impact zone. But if we that means a step function we have used, probability either 1 or 0, but if you know the actual probability with reference to distance or with or some other probability with reference to that abstract probability values, you may be thinking that your curve may be something like this. So, if I say now, okay, this is my FN curve for the department where I am working, maybe it is department 1 like this one. So, similarly, you can create your FN curve for some other department also, which may be like this, some other department may be like this. So, this will that is the interesting part. So, that means now this is department 1, this is my department 2 and this is my department 3. So, if I want to know the probability that 3 or more fatalities or frequency of 3 or more fatalities, so if you do like this, you see that here probability frequency value is less, here it is more, here it is even more. So, that means D1 your department is performing better in terms of that societal risk. Okay. So, that is why for all department, all jobs, all locations, your organization should have some societal risk, that plot, societal risk plot. I hope that this is meaningful to you, and I also hope that given such FN curve or individual risk plot, you will be able to interpret the results, and ultimately also you will be able to develop method that some kind of Excel sheet to calculate this kind of to compute FN curve. Okay. So, this is what is the totality in terms of risk assessment. So, let me repeat that in risk assessment, risk is in general P into C. So, that means there will be one model for probability computation, another one for consequence estimation. But this risk for what? Is risk for hazard or risk for accident scenario or risk for department? It actually we will start with risk for accident scenario. Like fire is a accident scenario, risk of fire. So, in your big organization, so there can be multiple places or locations, there can be multiple jobs, there can be multiple departments. So, whatever you do, there will be n number of hazards. Obviously, accident scenario will be identified from the hazards only, but accident scenario is the first. AS, then hazard, then your job, then your location, then your section, then your department, then your organization. And in order to identify hazards, whatever hazard identification techniques were told to you, please do it. And in order to find out accident scenario, use bow tie. In order to compute the probability and consequence values, go qualitative or quantitative approach, follow this. And then for societal risk and your individual risk, the approach what mentioned here today, it is better you follow this one. Thank you very much. I hope you enjoyed it.